In question 3, we have a diagram of a sprinter before the start of a race. In A part 1, we need to find the moment of the sprinter's weight W about her fingertips. Well, moment is force times distance. The weight is 520 newtons, the distance from the fingertips 0.26 meters, giving a moment of 140, the units being Newton meters. In part 2, by taking moments about her fingertips, we're to find the force on her back foot marked X. Well, the clockwise moment will equal the anti-clockwise moment. The clockwise moment is the weight times its distance. The anti-clockwise moment is the 180 newtons times 0.41 meters from the front foot Y, plus X newtons that we're trying to find, times the 0.63 meters for the rear foot X. Rearranging for X, we get 97 newtons. In part 3, we need to find the force F. Well, now the downwards force will equal the upwards force, and the upwards force, so the force F we're trying to find will equal the weight W acting down minus the two upwards forces we already know, X and Y. Putting in the values, this gives F as being 243 newtons. In B, the sprinter starts running, reaching a horizontal velocity of 9.3 meters per second in 35 meters. In part 1, we need to find our average acceleration. Well, we can use v squared equals u squared plus 2as, and u is 0 meters per second as she starts from rest. Rearranging, we get acceleration as v squared over 2s. Putting in the values gives 1.2 meters per second squared. In part 2, we need to find the resultant force needed to produce this acceleration. Well, force is mass times acceleration, and the mass is the weight over the gravitational field strength, and this gives 65 newtons.